All right, so we're on our last chapter of review. It's chapter 9. Even though we just finished chapter 9, it's probably worth doing a little bit of review before the final exam. So in chapter 9, we were solving quadratics. We were solving them, we were graphing them, we were analyzing them, all kinds of crazy stuff going on. So one of our solving methods was you use a GCF, and we do this when there's no C. So the common factor here would be 5x. I would have x minus 3 left equals 0, and I would make separate equations to solve for my two answers. So if I divide by 5, my answer is x equals 0, and if I add 3, my answer is x equals 3. We could also use quadratic formula. We said you use quadratic formula when you have all a, b, and c there, but one of our rules was that we always needed to equal 0 first. So before I solve this guy, I'm going to subtract 8 on both sides. I'm going to get 3x squared minus 2x minus 8 equals 0. And then I'm going to use my quadratic formula. So negative b plus or minus the square root of b squared minus 4 times 3 times negative 8 all over 2 times 3. If I type that into my calculator, I have negative 2 plus the square root of parentheses negative 2 squared minus 4 times 3 times negative 8 all over 6. So I get 2, and then I'm going to go back and change that to a minus, and I'm going to get negative 4/3. Finally, we learned we could solve by undoing, which we're going to do when there's vertex form or there's no b. In this case, it's vertex forms. The first thing I would do is add 5 on both sides. I would get 3 parentheses x plus 2 squared equals 12. I would divide by 3 on both sides. So parentheses x plus 2 squared equals 4. I would square root both sides. So I would get x plus 2 equals plus or minus 2. And then I would subtract 2 on both sides. So I would get x equals negative 2 plus or minus 2. Now negative 2 plus 2 is 0, and negative 2 minus 2 is negative 4. So my two solutions would be 0 and negative 4. On the next page, we're going to review how to graph. So if you have vertex form, your vertex would be the h and the k, which would be 1 and 8. Your axis of symmetry would be x equals the same x value from the vertex. Your y-intercept would be whatever you get when you plug in x is 0. So y equals negative 2 times 0 minus 1 squared plus 8. And when you type that in on your calculator, you should get 6. And your zeros are going to be whatever you get when your y value is 0. So you would have 0 equals negative 2 parentheses x minus 1 squared plus 8. And we're going to solve this by undoing. So I'm going to subtract the 8 on both sides. I'm going to divide by the negative 2. I'm going to square root both sides. And I'm going to add 1. So I'm going to have two answers. 1 plus 2 is 3, and 1 minus 2 is negative 1. Now I'm going to graph those. So vertex first, 1, 8. Axis of symmetry next. Y-intercept would be 6. Buy one, get one free. And the zeros would be 3 and negative 1. So I would just graph my parabola. There we go. If this parabola models a ball being thrown up into the air and then falling back to the ground, answer the following. What is the maximum height? Well, the highest this parabola goes would be 8 feet or meters or whatever it is in the air. When does it reach the maximum height? Again, it would be 1 because these are both talking about the vertex. From what height was the ball initially thrown? Now we're asking you about the y-intercept, which is 6. And when does the ball hit the ground? Now we're asking you about the x-intercept, which would be 3. We're not going to use the -1 because it doesn't make sense to have a negative time in a real life problem. We also learned that we could write equations of parabolas in vertex form. So our general equation was y equals a parentheses x minus h squared plus k. It tells me in this problem that the vertex is located at -3, 4, so this is my h and this is my k, and that the point -2, 6 is another point on the graph, so that's going to be my x and my y. Now I'm going to plug those numbers in. 6 equals, we don't know a, parentheses, my x is -2, my h is -3, so minus -3 squared, plus my k is 4. Now I'm going to solve this. So I know that a minus minus makes a plus, so I'm going to have 6 equals a parentheses, -2 plus 3 is just 1 squared. Now 1 squared is 1, so I'm going to have 1a minus 4, and then I'm going to add 4 on both sides. So I would get 10 equals a. Now that I know I have my a, I'm just going to write my equation. So y equals 10 parentheses x, and I know minus minus makes plus 3 squared plus my 4, my k at the end. Next, we learned about standard form. So for standard form, we said we can tell if this parabola opens up or down by looking at a, which in this case is positive, so the parabola opens up. To get the vertex, we needed 2 steps. First, we find the x, negative b over 2a, which is negative 6 divided by 2 times 1, which is 6 divided by 2, which is 3. To get the y, we just plug that in, so 3 squared minus 6 times 3 minus 7, which should be -16. My axis of symmetry would be x equals the same x as my vertex, so 3. My zeros would be whatever, my y-intercept would be whatever I get when I plug in x is 0. So I would just get -7 because the first 2 terms would both be 0. And my zeros would be whatever I get when y is 0. So 0 equals x squared minus 6x minus 7. Now I'm going to solve this one using the quadratic formula. So I'm going to have -6 plus or minus the square root of -6 squared minus 4 times 1 times -7 all over 2 times 1. Now if I solve this with the quadratic formula, I get 2 answers, 7 and -1. So I'm going to graph this. So I'm going to graph the point 3, -16. So I need a little more space. 5, 6, there we go. Right there. My axis of symmetry would be right here. My y-intercept would be -7. Buy one, get one free. And my zeros would be -1 and 7. So finally, I'm just going to draw my parabola. Now in the next example, it says, if this parabola models a scuba diver diving underwater and then resurfacing, answer these questions. At what depth does the scuba diver begin his descent? So now we're talking about the y-intercept, which would be -7. When does the diver reach his maximum depth? So now we're talking about the vertex, so I would say after 3 minutes or seconds or whatever. What is the maximum depth? So this is again the vertex, it would be -16. And so we would say 16 whatever meters or feet or whatever below the surface. And when does the diver resurface? So now we're talking about the x-intercept, which would be at 7. All right, thank you guys so much for watching. Have a great afternoon, and we are almost there. We're ready for finals.